Okay, so this is the conversion of benzene to 1,4-cyclohexadiene via the birch reduction. Okay, so in step 1, you have the benzene molecule, you have an H there. Of course you have an H on each of those carbons, but I'm only going to show that H and that H. Okay, in step 1, so you have a sodium atom and the benzene molecule. So that electron on your sodium atom transfers to that carbon on benzene, and that there pi bond between that carbon and that carbon goes there. Goes to between those two, and that pi bond goes to that carbon as a lone pair, so you get this intermediate. You still have that H there. Now you have an electron there, and now you have a double bond there, and at this carbon you have an H, and now you have a lone pair of electrons, and now you have a negative charge on that, and of course you still have that pi bond there. Okay, in step 2, so far we have used up one sodium atom. In step 2, this is what happens. So the starting material in step 2 is the product in step 1. So this is the product in step 1. Okay. Alright, so you have a negative charge on that carbon. So what happens next is that anion and a radical at the same time reacts with one molecule of ethanol, CH3. You have a lone pair there and a lone pair there. So that lone pair grabs that H, and that bond goes to O as a third lone pair. So now you have this intermediate. You now have two H's at that carbon. You have a pi bond there, a pi bond there. You have an H there, as well as a lone electron. So that is step 2. In the process, you are generating an ethoxide anion, OCH3. We have 3 lone pairs on that oxygen. That is an anion, which is neutralized by that Na plus produced in the first step. Okay, step 3. So the starting material in step 3 is the product in step 2. H, electron, 2 H's. Okay, so in step 3, that radical reacts with a second sodium atom. So what happens is that electron gets with that electron. So now you have a lone pair of electrons at that carbon. Still have an H. Now you have 2 electrons there. Now you have a negative charge at that carbon. And you do have 2 H's there. Okay. And in the process, again, you generate a second sodium cation. Next, step 4. So the starting material in step 4 is the product in step 3. Oh, sorry. So we have that H at that carbon with that lone pair and a negative charge. We do have 2 H's at that carbon. So the next step is that lone pair, that negative charge on that carbon, reacts with a second ethanol or methanol molecule, CH3. So that lone pair grabs the H off of your methanol, that bond goes to O as a third lone pair. And now you have your 1,4-cyclohexadiene. So in the process, you have produced this. You have produced two sodium cations, and you have produced 2 methoxides minus.